so you've been waiting for this problem because I know what you've been waiting for this because I know you wanted more. This is 2326 spiral matrix number 4. All right, what are we doing here today? One, two. Oh man, I could do more, but my head's just so big from all this Leetcode. You know what I mean? I'm just too strong. Okay, so what are we doing today? So today see, it doesn't matter how strong you are, you're always the same nerd who has no athletic capacity. Remember that, kids. I have to find my pen now. I love America. Okay. Anyways. Whew. Now that we got that out of the way. Alright, so spiral matrix is... There's a bunch of spiral matrix problems, and they all kind of follow the same format, but like most Leetcode problems, right, if they have the same kind of base, there's this small tweak that they add to make the problem different than the other versions of the problem, right? So spiral matrix 4, spiral matrix 3, spiral matrix 2, Spider-Man 1, Spider-Man 2, Spider-Man 3, they're all similar, right? There's just a little bit of a, extra catch that they introduce into the problem, try to, make it a little bit more difficult or make it a little different or whatever, all right? But in the case of spiral matrix is just this problem with this weird array traversal where instead of, where we normally traverse an array like from left to right and then top down, right? Like usually you look for each row and you look through each value in each row, right? So you look through this row, then you look through the next row, and you look through the subsequent row. In a spiral matrix world, you're like going all the way left to right, and instead of going to the next row, you start going down, and then instead of then you go left, and then up, and then right, and then down. So, what I'm trying to get at here is in a normal array traversal, you kind of do this, right? You kind of do this, like, boop, I guess. All right, you go left to right, left to right. Like so. That's an easy thing to do in traversal, right? Because you just look at each row in rows, and you look for each column in columns. Right? It's very easy to do that. Another easy traversal is, up, down like this. Or you had an array. Had an array like this. But in a spiral traversal, what you're trying to do is you're trying to go all the way left, and then down, and then right, and then left, and then down, and then right, and then left, down, and right, like this, right? So you're spiraling through, right? Not a very common word in English, but that's the idea, right? So instead of just doing a simple traversal where you're going from left to right or simple traversal down, you have to somehow loop through the array and make sure that you don't do things like, you don't overcount, right? Like, oh, oops, and then get stuck in this loop where you count these forever, or some weird situation where, you traverse through and then you skip elements or something, right? You need to make sure that you're spiraling through and you're catching everything. And that can be kind of just a tricky problem. It's not really a data structure and algorithm problem. It's really just okay, can you write code that meets these constraints, and how are you going to deal with that while keeping it clean? And I've never solved this problem before. I've solved other spiral matrix problems, and I've never really been able to write a super clean solution. And we'll see what I'm capable of doing today on the spot, okay? So what makes this spiral matrix problem different than the other ones? Well, let's go ahead and take a look. Okay, so you're given two integers, m and n, which represent the dimensions of a matrix. Okay, so in this problem, you are given m and n. So there's m rows, I'm guessing, and n columns. So it's an m by m matrix that contains the integers in a linked list presented in spiral order, clockwise, starting from the top left of the matrix. If there are any remaining spaces, fill them with -1. Okay, so what you're basically doing in this problem, right, is you're given m and n. So, for example, when m equals 3 and n equals 5, you're going to create this new array of size 5 by 3, or 3 by 5, sorry. I have this tablet, so I can actually 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5. Make that perfect dimensions, right? And then these are m equals 3 here, n equals 5 here. And what you're also given is a linked list. Okay, so you have this linked list 302 68179 68179 42550 42550. Okay, now basically what we're going to do in this problem is we're going to take this linked list and we're going to spiral it through this array that we created, right? So we created this new array, it's all empty, and then we're going to start placing in the values one at a time. So I put the 3 in there, I put the 0 in there in a spiral fashion. I put a 2 in there, I put a 6 in there, I put an 8 in there. Now where's the next place I go? I'm trying to follow this spiral pattern. So I put the 1 here, the 7 here, the 9 here, the 4 here, the 2 here, the 5 here, the 5 here, the 0. And then now it's like, well, I've run out of elements and there's still additional space. So the additional space gets just -1. Okay. So basically, in order to interact with this linked list, right, linked lists have specific operations associated with them, and usually Leetcode problems will show you those. So if you want the next value in a linked list, you just call next, right? So really, if we start here, we'll have like the head, right? We'll be pointing, apologize. Your head will be pointing here. And if you want to get to the next element, you just say, you know, head equals, well, there's a lot of ways you can do it, but the only way to get it from the list is say head equals head.next, right? Which that will take this thing and move it over 1. So that's the basic property of how this works, right? So the issue in this problem is not, the issue in this problem is the spiral, right? How, it's easy to like write it through, but how are we going to like programmatically figure out how to spiral through an array in a clean manner, right? Now, I'm tempted to do directions, and that's just off the top of my head, right? So I guess one way we can do a spiral is just start by thinking about, so let's just say we're in, let's do that 3x5 again. Let's look at that 3x5, and let's think about how we're going to walk through this array. Okay. Now, I like doing directions. Now, there might be a better way of actually doing this, and I just don't know it. But, you know, I like starting with the idea of, well, if we're in this position here, right? Let's say my position equals 0, 0. And I need to start moving. Well, what's the direction I'm going to start moving? I'm going to start moving in the right. Okay, so I'm going to say, okay, I'm going to move myself to the right and make my position 0, 1, and I'm still moving right. I'm going to do that again and make my position 0, 2, 0, 3, 0, 4. Now I'm going to mark these as saying I've already traversed these elements. Now I'm here, and I can't keep moving right because I'll be out of bounds, right? So which direction should I change? Now I need to go down. Okay, so now I'm going down, and I keep moving and keep moving. I get here, I can't keep going down, so which direction should I go? I should be going left. So I went from right, and then when I couldn't keep going right, I went down. When I couldn't keep going down, I started going left. Okay, left, 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 left. If I can't keep going left, what do? I go up. Okay. Oopsies. So left and then up. Now the next thing to consider here is the new boundary, right? Because at this point, if I'm thinking about what I've actually traversed, I've traversed all this. Now I don't want to keep, I need to spiral through, right? Like one thing to notice here, sorry, I need to maintain a safe distance to the mic, a fist distance from the mic. So if I'm at this distance here, I need to go all the way over, all the way over, all the way over, but I don't want to go back and traverse 3 again, right? Notice how it makes this right turn here. So I need to somehow figure out how am I going to capture that to think about boundaries, okay? So if I'm going up and it's a cell I've already seen, well, there's a couple ways we could do this now that I'm thinking about it. Think about directionality. So if you're going up and you can't go up anymore, what direction do you go? You go right. So that's kind of how I think about this, right? Is to think of this guy being moving in a certain direction. And if he reaches something that he cannot pass, right? This is his current direction. I say the direction now equals what's next for this direction. Meaning, you know, the next is, well, the next of up is, if you're going up, what's the next thing you're supposed to do? Go right, right? If you're going right, the next thing you do is go down. If you're going down, the next thing you do is go left. And if you're going left, the next thing you do is go up. So if you ever reach a situation where you need to change directions, there's a clear manner in which you're supposed to do that when you're doing the spiral array, okay? Now, this is all like all over the place and probably doesn't make sense, and you're like, okay, how are we going to incorporate this idea? But that'll make sense in a moment, okay? So what I'm going to do is, how do I know when I need to change directions? I change directions when when what? Out of bounds is the first condition, right? Like when our guy was here and he was trying to go right. You know, this is condition 1. Meaning that this is the condition where you're trying to go out of bounds and you need to change directions. But you also change directions if already traversed cell. What do I mean by that? What I'm saying is if I have this P here and I'm trying to go up, well, I've already traversed this cell, so I need to change directions too. That would be the number 2 case. And that kind of captures everything, right? There's we know how we change directions. If we think about this in terms of directions, right? We're going right. If we're going right, the change direction is going down. If we're going down, the change direction is left. If we're going left, the change direction, we go up. If we're going up, the change direction is right. When do we need to do that? We need to do that when we go out of the boundary or we encounter a cell that we've already traversed. Okay? So, So are any of the cells actually equal to -1? Node value is between 0 and 1,000, okay? So what I'm thinking about doing here is instead of building the array, what I'll do is I'll have a default dict, and you can imagine that we're just in a sea of, well, and how would you know it was out of bounds? Kind of the same thing. All right. Sorry, I'm trying to think about the best way to do this to keep it clean. I guess another thing to think about is, before we continue, is how do values change based on the direction, okay? So we'll think about our position here, P, okay? And P has an X position, and a Y position, okay? So if we have P that's represented by an X position and a Y position, how does that change based on what you're doing, right? And instead of saying X position, Y position, let's just call this row and column, okay? So if the direction is right, what does that mean in terms of the P position, right? If P is going right, right, so P was once here, and now it's going to end up being in this next spot. What does that mean for R and C? Well, the row is the same, right? Because I'm going to the right. The column is what increases. So I go R and C plus 1. Okay. What if I'm going left? So if left is the position, I'm staying in the same row, but I'm decreasing the column. What if I'm going up? Right, I'm trying to go up a position. Well, then that would mean that now my row is decreasing, right? Because you can think of an array as 0, 0 is the top left, right? So, right? Like this is the 0, 0 element in the array. So if I'm here and I'm trying to go up, I'm trying to decrease the row. So that would mean we're doing row -1 column. And then what if I'm trying to go down? Well, I think you can kind of figure this out. I'm trying to increase the row and I'm staying in the same column. So I just wanted to put that there because we need kind of all this information. And now I'm trying to figure out, okay, how am I going to take all this information and put it into the code? Okay. And the way that we'll do that is, well, to get the next position, I'm going to create this function called def next. Well, not next. I'll just call it n. Terrible naming, but whatever. Of the current position. Okay. And we'll just not call it position P. We'll call it our XY position, row column position. Okay. So there's a row of the column in the current direction that it's going. Okay. So one thing we can do is we can just increase row and column based on the current way that we're going to do it. Sorry, there's so many ways to do this. So if direction, we'll just deal with each direction independently. Okay, whatever. So if direction equals up, if direction equals down, if direction equals right, or if direction equals left. And it's always going to be one of these. There's just no switch cases in Python, so it's kind of annoying. So I would rather do a switch here, but this is fine. So if we're doing direction equals up, what does that mean for what we return? Well, if we're going up, what did we say was the... Oh my gosh, opening all of the wrong things. How unprofessional. If the direction is up, we go R-1, R-1, C, and D. If the direction is down, I'm assuming that we're moving in the same direction here. I'm not accounting for situations where we need to change. If the direction is right, we increase our column. If our direction is down, we return left. We're going left, D, okay? So what if so this will be else if then. So I'm going to set our new direction like this. I'm so sorry, guys. So what happens when you do things on the spot? I'm trying to think about the best way to do this while keeping it clean. And I'm going to call it our new, I'm going to add this so that it's different than what's given. So this will be like our new row, our new C, our new D. Okay. And then what I'll do is I'll say, this is what I'm going to try to do. And I'm going to make sure that it doesn't break the constraint. So if any of the conditions are wrong, so if RR is not between 0 and N, or if we're looking at our row, it can't be larger than M, right? So basically saying if it's not in the boundaries of, you know, M that's given here, maybe you can't, I wonder if you can't access, we'll see. Might not know what M is. I can't remember how Python deals with this, but basically if we're outside of the range of, if we're outside of the ranges of the rows when we make this move, or if we're outside of the range of the columns by making this move, less than or equal to, or if we're in a location where we've already set the value, meaning it's not equal to -1, and I'll explain what that means in a moment. All right. Well, then we need to change the direction. So now our new direction is this array evaluated at our current direction. So if our current direction is up, what are we supposed to do? We're supposed to go right. If our current direction is right, what are we supposed to do? We're supposed to go down. If our current direction is down, what are we supposed to do? We're supposed to go left. And if our current direction is left, what are we supposed to do? We're supposed to go up. Okay? So basically what I'm saying here, what I'm trying to get at, and then I'm going to just call return n on RC of our new D here. So it's kind of a way to like correct if you do this wrong. So what we're going to do instead is we're going to start by creating this res array. And each value will be -1 times n for blank in range m. So what's going on here basically is, first thing I'm going to do is I'm going to create gosh darn it. The first thing I'm going to do is I'm going to create an array of the size of what I'm sending out, like this, right? So I'm going to create this array, and I'm going to make it empty. I'm going to make the values all -1, and I'm going to start traversing and setting the values, setting the values, setting the values, setting the values, setting the values. And when I go outside of the range, I'm going to try to keep going right initially. When I go outside the range, like I end up over here, I'm going to move myself back and change the direction so I'm going down, going down, going down. So I keep going down, I keep increasing this. I go outside the range and I say, oh shoot, I went outside the range because I get up over here. So I say, okay, shoot, I need to change my direction and try again with the original value. So I change my direction, try again with the original value. That means I keep going back, back, back. Make these the same dimensions here. Then I try to keep going left. I can't, I get outside the range. So what do I need to do? I need to start going up. Now here, when I get here, this value will not be -1. So then I know I need to go down and change my direction. Like that, and such, and so on and so forth. And I just deleted a bunch of code. Okay, so I'll explain this better when this charges up a little bit. Okay, we're good here. So to explain this again, what I'm basically trying to do is I'm basically saying, okay, you know, I have this position array here. I'm going to create the initial array with all -1s because it ends up being -1 in the end anyways, right? And I'm going to start with my position being x, y, the direction, 0, 0, and I'm going to the right. Okay, so I'm going to start here. When I finish this value, I'm going to paint it something, right? It's going to be something new. I'm going to go here. I'm going to move. Right, I'm going to have P again. And I'm going to try to go right again. So I'm going to increase. I'm going to keep going right, keep going right, keep going right. Once I get here, I'll have had colored all these values. So I'll end up moving all the way over, right? Because I keep going right, I keep going right, I keep attempting to go right. And at one point, I'll go so far right that I'll be outside of the boundaries of the array, right? Like I am in this case here. So then what I'm going to do is say, okay, shoot, I've gone outside the boundaries of the array. So I'll move myself back. So I'll try to go back to R and C where I was before and change my direction, right? So I was going right here and basically it led me astray. So what I'll do is I'll move myself back and I'll change my direction to what's next and then continue there. Now I'm going down this way, right? So then I paint this, and I end up getting here going down. Of course, I paint these as I go through. I end up here going down, and I say, okay, I've led myself astray. I'm outside of boundaries, so I'm going to change my direction and put myself back in the spot where I need to go. I go all the way left. I end up going out of boundaries, change my direction, go all the way up. I end up here. I'm not outside of the boundary, but there's another condition there where if I've already painted the value to do the same thing, so now I've gone too far, so go back, change my directions, and continue. Go back, change my directions, and continue, so on and so forth. Okay, so that's what this code basically does. So our x, y, and our direction initially are 0, 0, and we're going right. Okay, let's make sure all this is right. If I'm going down, I increase the row. If I'm going up, I decrease the row. If I'm going right, I increase the column. If I'm going left, I decrease the column. If I'm not in this range, or the value is not equal to -1, if it's up, you end up going right. If it's right, you end up going down. If it's down, you end up going left. If it's left, you end up going up, and you run it again with that new idea of the direction. All right. And we'll say while head res of x, y equals head dot val. We'll increase our xy value in our direction by calling this function, and we'll say head equals head dot next, and we'll return head, or no, we'll return res at the end, and we'll cry. Okay, so I called it XY here, and I should be calling it RC, row column versus XY. Apologize. Row column XY. Don't know if it has access to this M. Cannot unpack. Oh, otherwise, we return. If this isn't the case, then we're good. So we can just return our new RR, CC, and DD values. All right, cool. Let's go ahead and submit that and cry when it doesn't work. Runtime error, maximum recursion. Why? What's going on here? What did I miss? Let's see. So there's some case here. Well, it's 10 by 1. One, two, three, four, five, 6, 7, 8, 9, 10. Okay, so it's not like there's too many values. You keep going right. Head equals head down next. It's weird. Let's see. Oh, if it's 10 by 1, it looks kind of weird, right? It's like a skinny, tall thing. So let's walk through this and try to figure out what's going on here. So a 10 by 1 is like this. So it's not really easy to spiral through this, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess 10 here. Okay. So you initially try to go right. You mark this, you try to go right. You can't. So you go down. And you just go down. So what's the issue here? Okay, I'm gonna print out RC and D here. Make sure I'm not RCD, lowercase r. Try to figure out what value I'm missing here. Something wrong here. I apologize for that, guys. It's embarrassing. But I'm not seeing. So 0, 0 tries to go right, can't. So 0, 0 now is going down. Okay, so it does pretty good all the way till 9, 0. Let's see where it gets to here before it starts going crazy on us. Oh. Because the last value and then it has nowhere to go. Right? It has nowhere to go in the end because it literally fills the whole array. That's interesting. So the problem is when you fill the whole array, there's nowhere to go. So then you get stuck forever because you've already filled the whole array. So it's like, what's the next place to go? There is no next place to go because I filled the whole array. So how are we going to deal with that here? So we'd say if so we can increase this before we continue. And we'll say only if head. Right? There has to be something else to consider in order for us to even walk through the remaining things that could be an issue, hypothetically. So basically what I'm saying here is if head, right? Because head is the fact that there's something in the array. So if we've exhausted everything, there's no point in trying to change directions anymore. It doesn't matter anymore. We're on the last one. Okay. So that should help us deal with this situation where there's nothing left. There's nothing left and there's no point in trying to change directions. If you fill the whole array, you're never going to find the next place you're supposed to go. So that was kind of why it was getting stuck there at the end. Okay. So let's make this a little bit shorter just to play a little fun game here. Look at that. Look at how beautiful this is. You can say head. Head dot next. I kind of wonder what happens when you call a... Well, I don't want to do it like that, actually. That's fine. See, so things can be done pretty cleanly. I mean, it's not perfect, but, you know, you can keep things pretty short and relatively short in a spiral if you just think about it in terms of directions. So what is the run and space complexity of this? Okay, so for time and for space. Well, we have to create this array. It's m by n. We have to traverse that whole array. It's m by n. We don't do anything strange in there, right? We look at all the elements in head, and it never exceeds the amount of elements that are actually within the actual array. And, well, we have to look at all of them, right? So we at the worst case, we have to fill the entire array. When we fill the array and we make decisions, we're just doing constant things, right? We do constant checks to figure out, okay, what's the next place that we go to? This recursion function would only get called once, right? Because you only have to change the direction once to fix the situation, right? If you go outside of the boundary, you touch something you're not supposed to touch, you just change the direction and you go down. So it's a one extra operation. So it's not like this would call this any set number, non-constant number of times. So for time, that's just big O of m times n. And then for space, well, we have to create this res array and then fill it up. And that's also going to be m by n. There's no recursive stack space or anything here, right? Because it would only call itself at most once. Okay. All right, guys. Hope you have a beautiful rest of your day. Peace out.